Hello everyone, how are you today? I hope everyone is doing well. My name is Tasya Septiani. I am from Group 8 and we were assigned to do the problem on 3.71. So without any further ado, let's get started. In this problem, here we have a counter shaft which carrying two V-belt pulleys as shown here. It's stated that the pulley A receives power from a motor through a belt with the belt tension shown here. It is not a straight tension, it has an angle which is 45 degrees. And then the power is transmitted through the shaft and delivered to the belt on the pulley B. We assume the belt tension on the loose side at B is 15% of the tension on the right side. Since we assume that the belt tension on the loose side at B is 50% of the tension on the tight side, so T2 is equal to 15% T1 or 0.15 T1. We also have some other knowns from the figure, which is the diameter of pulley A is 250 mm or 0.25 meter, and the diameter for B is 300 millimeter or equal to 0.3 meter, and then the length from O to A is 300 millimeter equal to 0.3 meter. The length from A to B is 400 millimeter equal to 0.4 meter, and the last one is the length from B to C, which is 150 millimeter or equal to 0.15 meter. Now, the questions are: A. Determine the tension in the belt on pulley B, assuming the shaft is running at a constant speed. B. Find the magnitudes of the bearing reaction forces, assuming the bearings act as simple supports. C. Draw shear force and bending moment diagrams for the shaft. If needed, make one set for the horizontal plane and another set for the vertical plane. D. At the point of maximum bending moment, determine the bending stress and the torsional shear stress. And the last one is, at the point of maximum bending moment, determine the principal stresses and the maximum shear stress. So, without any further ado, let us jump to the step to answer these questions. First, we consider Newton's second law for torque in rotation about the x-axis. Here, the counter shaft is known to rotating at constant speed. So, the summation of these torques or moment must be equal to 0. And we have to take note that we assume counterclockwise to be positive. Torque is where the force is being multiplied with the distance from the pivot point to the point where the forces act. Here is the radius or diameter over 2. So we can just simply to continue the calculation by put everything known from the figure or from the known that we have, and for the plus and minus sign we see it from the direction of the moment due to the forces. Here we have 300 Newton is to be positive because the direction of this force 300 Newton force resulted a counterclockwise moment, so the sign is plus. Also for 45 Newton force, it resulted a clockwise moment, so the sign is minus. The same thing goes to T2 and also T1. Here we plug everything in and then we simplify the equation from here to here, and we got the equation 1 is T1 is equal to T2 plus 212.5. For the second equation, we put the known that T2 is equal to 0.15 T1, while from the previous slide, we obtained the equation for T1 itself. So, in this step, we can just simply substitute in the T2 equation. this, and we simplify the equation to become like this, and we got the value for T2. After that, we substitute back to the T2 value to the equation, which is 37.5 is equal to 0.15 T1, and finally we got the value for T1. And we are done with part A. Now we proceed to draw a free body diagram. This is the free body diagram where all the forces is going up for CY, AY sin 45, and also OY. Here we assume that sigma Fy is equal to 0 and the direction to the up to be plus. The equation is OY plus AY sin 45 plus CY is equal to 0. 45 here is the degree that we have known before. And then all the sign is positive because all the forces is going up. For AY, we obtain the value from first 300 Newton plus 45 Newton. And from here, we can know the equation to becoming like this. Now we work with the moment about the z direction. Moment is where the force is being multiplied by the distance. Here, for the force of AY sin 45, it is times 0.3 meter. And then for the force of CY, it is multiplied by 0.3 plus 0.55, which is 0.85. And it is equal to 0. We simplify the equation to become like this, and we can obtain the value of Cy is equal to a minus 486.1 Newton. And then we go back to the equation above to obtain the Oy. We know the value of this, we know the value of this, and we can just simply find the Oy. Oy is minus 157.85 Newton. We proceed in a similar way in order to obtain CZ and OZ. First, we need to draw the free body diagram. Here, almost all of the forces is going down, except for AY cosine 45. And then for this force, it is the force that as the summation of T1 plus T2. We have the same assumption where sigma Fz is equal to 0 and the sign will be plus if the direction is going up. This is our equation where almost all of the forces is minus except for the AY cosine 45. And as what I've been mentioned before, that this force is the summation of T1 plus T2. We obtain the value of T1 and T2 from the calculation above and we plug it in here. And then we simplify the equation to becoming like this. Now, we have to work with the moment to find the value. As what I've been mentioned before, that moment is force multiplied by the distance. For AY cosine 45, it is 345 cosine 45 times 0.3. And then for the summation force is multiplied by 0.3 plus 0.4 or 287.5 multiplied by 0.7. And then for CZ, it is multiplied by all of the summation of the distance, which is 0.85. And then it is equal to 0. We simplify the equation to becoming like this and plug everything in. and then we can obtain the value of CZ, which is minus 150.86, sorry, CZ is equal to minus 150.66 Newton. And then we go back to the equation above to obtain the OZ. We know the value of this and also this. And we can just simply find the OZ. OZ is 107.11 Newton. And now, let's recall all the values that we have obtained. Cy is equal to minus 86.1 Newton. Oy is equal to minus 157.85 Newton. Cz is equal to minus 150.66 Newton. And the last one, Oz, is equal to 107.11 Newton. And after having obtained all the bearing reaction components, we are now able to compute the total direction forces for C and O. For C, it is equal to square root of Cy square plus Cz square. We plug the values here and here, and then we can obtain the C is 173.53 Newton. The same thing we do for O. O is equal to square root of Oy square plus Oz square. We plug everything in and we obtain the value for O is 190.79, sorry, O is equal to 190.76 Newton. And we are done with part B. So now is the shear force diagram. Shear force diagram based on the forces in the y direction is shown here. This is the value that we have obtained before. And then this is the shear force diagram based on the forces in the z direction. The same thing like before, this is the forces that we have obtained before. So now we have to draw the bending moment diagram. Bending moment diagram is the area of the shear force diagram. In this case, we have to obtain this from minus 157.685 multiplied by 0.3, and we got this value. And this is the bending moment diagram in the z direction. To find this value, we do the same thing like before, which is find the area from the shear force diagram. After we draw the shear force and bending moment diagrams, we can note that point A has the greatest total bending moment. So MA is equal to square root of minus 47.36 square plus 32.13 square. And MA is 57.36 Newton meter. The bending stress at the point of maximum bending, point A, can be computed as follows. Sigma B is equal to MA multiplied by RC, or here is DC over 2, over IC. IC is pi DC to the power of 4 over 64. Now we plug IC here and we simplify the equation for sigma B to be 32 MA over pi DC cubic. And now we plug all the values to the equation here, plug everything in, and we obtain the value of sigma B is equal to 72.867 MPa. The torsional stress at the point of maximum bending can be obtained as follows. Tau T is equal to T multiplied by RC, or here is DC over 2, over GC. GC here is the polar moment of inertia. So GC is equal to pi DC to the power of 4 over 32. We plug this GC to here, and we simplify the equation for tau T is 16T over pi DC cubic. And we have to put the nonce to the formula. But first, we have to find the T, or the moment, the torque. Torque is the force multiplied by this distance. Force here is 300 minus 45 because these two forces has different directions. So 300 is plus and 45 is minus. And we multiply it by the radius, which is 0.25 over 2. And we obtain the value of T. And then we plug it in here and we obtain the value for tau T is equal to 20.29 MPa. Up until this point, we have finally done with part A, B, C, and D. So let's solve for the last part, part E. For part E, we have to obtain the principal stresses, sigma 1 and sigma 2. Principal stresses or sigma 1 and sigma 2 can be obtained with this equation. Sigma 1, sigma 2 is equal to sigma x plus sigma y over 2 plus minus square root of sigma x minus sigma y over 2 squared plus tau xy squared. Here we assume that sigma y is equal to 0 because the shaft is only rotating on x direction. So sigma y is 0. And we have the equation to become like this. And we can just simply substitute all the values that we have known here for sigma x. And we can find the sigma 1 and sigma 2. Sigma 1 is equal to 78.15 MPa, while sigma 2 is equal to minus 5.27 MPa. Finally, we can compute the maximum shear stress. The maximum shear stress can be computed with this equation. Tau max is equal to sigma 1 minus sigma 2 over 2. We plug the known values here and we obtain the tau max is equal to 41.705 MPa. So that is the last part of this question, which is part E. So thank you for your attention and see you for the next assignment.